Hey, this is Mr. Leach with Simpson Math, and today we are going to be talking about graphic transformations using Geogebra. You can find Geogebra at geogebra.org. You can find the link in the description below. You can download it, or you can just run Geogebra from the website directly. When given the option, select Algebra. Let's turn the grid on, so I'm going to toggle down the Graphics menu and turn the grid on, and click down on the input, and let's type in f open parentheses, and it actually creates the closed parentheses for you as well. F of x equals, let's do sine of x, and hit enter. By default, Geogebra uses radians instead of degrees. If you wanted to use degrees, you would have to add a degree symbol after the x, which can be found over here in the symbols. So what we need to do is we need to change this x-axis to radians. So move your mouse so that way you're on the x-axis and right-click, and select Graphics, click on X-axis, and change the unit to pi. So that way we're dealing with radians. I want every major tick to be a half pi, so select Distance and select pi halves. And as a nice visual thing, I'll have the tick marks also have little in-between tick marks as well. We can see the sine graph nicely. We're at pi halves, it's at 1, at pi it's at 0, so forth. So like I said, we're going to be doing graphic transformations. So let's first create another function called g of x. So g of x is f of x minus 2. Now notice I'm typing in f of x and then minus 2. When I hit enter, look what happens. Listed over here on the left, it says g of x is sine of x minus 2. So it replaced the f of x that I typed in with sine of x. And we can see visually that this graph has moved down 2 units. So what do you think would happen if we create the function h of x is f of x plus 5? Yeah, it's just going to move the function up 5. These are our vertical translations. What's also interesting is you can click on the original green function and just drag it around, and you see that the red function is always going to be 2 units below, and the blue function is always going to be 2 units above. I'm just going to hit undo to move that back. I can hide these functions by clicking on the blue dots. Now let's define k of x is 3 times. To do the times, hold down shift and then the 8 key to get the asterisk, 3 times f of x. So what happens here is our output, which is our sine of x, it took every one of these y values and it multiplied it by 3. So this value is at 1, so 1 times 3 is 3. This value here is about a third. That third gets multiplied by 3, and so now it's at 1. So all those y values get multiplied by 3. So the amplitude is now 3 instead of just 1. So what do you think would happen if we have L of x is negative 3 times f of x? What do you think that negative is going to do? Or since we're multiplying our outputs, our y values, by negative 3, that positive 1 now became a negative 3. The negative 1 became a positive 3, and all the values in between. Lastly, for this type, let's take a look at m of x. So m of x is 1/3, so 1 divided by 3, times f of x. So what do you think is going to be different about that 1/3? Yeah, so this 1 is now only at a third. All the y values get multiplied by 1/3, so that amplitude shrinks in to just 1/3. You can do the same thing and you can drag around this function and you can see these changes. One note, move this function, let's say, up about 2 units. It's behaving this way because this 3 is multiplying this entire f of x by 3. So it's really as if this function's moved up 6 instead of just up 3. So far we've just looked at vertical transformations. Let's take a look at the horizontal transformations. So let's do n of x equals f of, and we're going to do x plus pi fourths. So x plus, click on the symbol over here and click on pi. It's down here in the bottom right instead of with the rest of the Greek letters. Pi divided by 4. And so here, if you notice, it's actually shifted left pi fourths. Pi fourths is this distance here. So all of the x values have actually moved left pi fourths. And that might seem a little counterintuitive because I'm adding pi fourths, but it actually did, as you can see, move the function left pi fourths. Now let's do the same thing, but let's do minus pi fourths. So let's do O of x equals f of x minus pi fourths. So as you can see here, this function O of x has moved right pi fourths units. Now let's do P of x is f of 3 times x. So our original function, f of x, has what we call a period of 2 pi. These trigonometric functions have periods because they start repeating themselves. And so for our original function, function f, it takes 2 pi for it to go through a full cycle or a full period. Now, when I multiplied my x's times 3, it actually collapses the period down to just 2 pi thirds. It takes 3 full periods of this sine of 3x to complete just one of the original periods of sine of x. So that period gets collapsed down to just 2 pi thirds. What would happen if I multiplied the x's times 1/3? So let's do q of x is f of 1/3 times x. In this case, this period is actually now 3 times bigger. I'm going to move this graph here a little bit to the left, and you can see that it takes a full 6 pi in order for that red function, q of x, to make a full period. It's because it's taken this original 2 pi period and multiplied it by 3.